Hi, this is Wendy, and in this series of videos, we're learning about iteration or looping. In the first video, we learned about three kinds of loops in Java. In this second video, we'll look at nesting loops and other structures. In the third video, we'll learn how to use loops for data validation, and in the last video, we'll talk about common errors that programmers often make when working with loops. In an earlier video series, we talked about nested selections. As you can guess, you can also nest loops inside each other too. Nested loops allow you to perform more complex algorithms and allow you to even do some basic things like print a table of values in rows and columns. Let's get right in there and look at a nested loop example. In this example, we see two for loops. Now, I only chose for loops because they're a bit easier to follow with this kind of example. You don't have to use for loops. Nested loops work with any kind of loop. Note also that in the first for loop, which we call the outer loop, I use the counter variable I. In the second for loop, which we call the inner loop, I use the counter variable j. If you're doing nested counted loops, you can't use the same variable counter for both loops. They must have different counter variables. Let's trace this code, and that will help us understand how nested loops function together. So we start off with our first or our outer for loop, which is counting the variable I. So I'm going to start off by initializing my variable I. It starts off with a value of 1. It says so right there, int I equals 1. And then to enter the loop, we have to make sure that we evaluate this condition and see that it's true. In this case, I less than or equal to 3. If we look at the current value of I right now, which is 1, that is in fact less than or equal to 3, so this is true. This means, of course, that we can enter this for loop that's counting I. Now, the first statement we encounter inside our for loop is another for loop. This is our inner for loop, and it is counting the variable j. As we said before, you have to make sure that if you're using for loops, or any counted loop for that matter, your counter variables must be different. You can't have the same variable declared twice. So we usually, when we have nested loops like this, we usually use I and j. So I'm going to start off my inner loop by taking the variable j and creating it and initializing that to 1 as well. And I'm going to move these out of the way. There we go. The other thing, of course, is I have to evaluate my condition. My condition for this inner loop is j less than or equal to 4. If I look at the current value of j, which is 1, that is true. It is, in fact, less than or equal to 4. So since the condition is true, of course, I enter this inner for loop, and I see a print statement, and it's printing the string x. You could have put a char here as well. I think I just put a string out of habit. So I want to print the letter X. I'll do my output down here under the code. Because this is a print, there's no new line at the end. That means the next thing that's output is going to go right after the X, and it's going to be that way for this whole inner for loop. Once I finish the print, I then come to the closing brace of the inner for loop. Braces nest together just like elements or tags do in HTML. So this opening brace here matches this closing brace here. So these guys go together. So when I hit this closing brace, that's the closing brace for this inner for loop, the one that's counting j. So where do I go? I loop back up to the top of this inner for loop. I don't go up to the top of the I, the outer loop. This brace matches the opening brace for the inner loop. So it's the inner loop right now that I'm iterating. So when I return back up to the top of my inner for loop, before I can do anything else, I have to finish the first iteration by incrementing j. So I look for my j variable, I increment it by 1, it becomes 2. Now I can reevaluate my condition to see if I'm able to do another iteration of this inner for loop. So I look at the current value of j, which is 2. Is that less than or equal to 4? Yes. So that means this condition is true. I can enter this for loop again. Again, I'm working with the inner for loop. So I execute the code inside the inner for loop, which is x. Remember, we left off on the same line, so we're going to print an x right there. My lines are kind of wiggly right now. It's just because of the layout of stuff I have on my desk. It's a bit awkward, but don't worry about it. That's a row of x's, beginning a row of x's. So Once I finish the print, I then hit the closing brace. That causes me to loop back up to the top of my inner for loop, where I must increment j by 1 before I can do anything else. Once that's done, j is now 3. I then reevaluate my condition. Is 3 still less than or equal to 4? Yes, that's true. So I'm going to enter this for loop again, where I'm going to print x on the same line as the previous x's. And once the body of the for loop is done, I loop back up to the top again of my inner for loop, and I increment j to 4. So j gets incremented to 4, and I reevaluate my condition. Is 4 still less than or equal to 4? Yes, that's true. So this is going to allow me into my for loop again, where I'm going to, surprise, surprise, print x. Then I loop back up to the top of this inner for loop. Of course, to finish that fourth iteration, I have to increment j to the next value, which is 5. Then, to see if I re-enter my loop again, I have to reevaluate my condition. Is j, which is 5, less than or equal to 4? No, that's actually false, which means since the condition is false, I now terminate the loop and I move on with the rest of my program. After the loop, I then encounter this print line statement. Now you might be wondering, why is there a print line statement there? So this should now become obvious. Remember that a print line with nothing in it just prints the new line. So it's a great way to just print a blank line or print a new line character in this case. So since we left off right here after the last x, adding a new line to that will bring the print cursor down to the next row or the next line of output. So that means the next thing that's going to be printed will be on a new line immediately under the x from the previous line of output. So that statement is done. We continue. We now hit the closing brace of the outer for loop. Again, this brace here matches this brace here. So these braces match. So these are the outer loop braces. So when I hit this outer loop brace, I then loop back up to the top of my outer for loop. I still haven't finished the first iteration. I have to increment I before I do anything else. So I gets incremented to 2. Then I can reevaluate my condition. Is I still less than or equal to 3? Well, I is 2, so that would be true. So that means I now can re-enter the outer loop. I am going to reiterate the outer loop. I just finished the first iteration, which printed a row of x's. Now I'm going to continue with the next iteration. Now, when you reiterate a loop that has another loop inside it, what happens is when I enter this outer loop, the first thing I encounter is the beginning of my for loop. We are going to re-execute this for loop. That means we are going to redeclare the variable j and initialize it to 1. So this is all gone, and we're starting with a new j, which has a value of 1, because that's what we initialize it to. Then we have to evaluate a condition, is j less than or equal to 4? This is true. 1 is less than or equal to 4. So this restarts the inner loop. The inner loop is going to execute all over again. So as you could probably guess, or at least you should be able to guess, when we did this whole loop the first time, it printed 4 x's in a row. It is, in fact, going to do the exact same thing. I'm not going to trace the whole thing. We've done enough for loops now, but we have started j off at 1. We've checked it is less than or equal to 4. We're going to enter the loop. So of course I encounter the print statement. This means I'm going to print the letter x. This is where I left off down here at the beginning of the next line. You might remember that from the previous iteration of our outer loop. So when I do the print, my x is going to go right here under the x from the previous line of output. Once I finish the print, I then hit that closing brace. Again, this brace belongs to the inner loop, so I loop back up to the top of my inner loop. Before I can do anything else, I must increment j to 2. And then I reevaluate the condition. 2 is still less than or equal to 4. That's true. I'm going to enter my loop, and I'm going to print an x. And I'm basically going to repeat this 2 more times. I'm going to increment to 3, which is still true. That's going to cause me to print another x. I'm going to increment to 4. I'm going to do my last iteration because this is still true. I'm going to print another x. And then I'm going to loop back up to the top. It's going to increment to 5. And then this is no longer going to be true. It's going to be false. That's going to cause this to finish the inner loop. And then my print line will add a new line so that the next output will go on the next line. Then I loop back up to the top once again of my outer loop, and I'm going to repeat everything that we did when we began. And I'm going to execute my I++, of course. So I take my variable I. Again, I have to finish this second iteration of my outer loop. So I is now 3. Is I still less than or equal to 3? Yes, that is still true. So I'm going to re-enter my outer loop, and I'm going to re-execute all of this code again. So as you can guess, that's going to print a row of 4 X's followed by a new line. We don't have to go through this whole inner for loop again. Then we're going to iterate our outer loop, and we're going to have to, as usual, finish the iteration by incrementing I. It's going to increment to 4. We check our condition. Is I still less than or equal to 3? No, that is false, which means now the outer loop has terminated. So this is the output that we get after we iterate these nested loops. Now the key thing to note about nested loops is that you have to complete all of the iterations of the inner loop for each iteration of your outer loop. So we notice that our inner loop always executes 4 times in total. So it's going to do 4 iterations for each one or single iteration of our outer loop. Now try this exercise. See if you can manually determine the output of this set of nested loops. Go ahead and pause the video, trace the code manually, and then resume the video to see if you did it correctly. So once again, we're going to trace the code manually, and you can see if this matches the answer you got. So I start off by setting up my variable x. So I declare the variable x and initialize it to a value of 1. Then I start my while loop. My while loop condition is while x is less than 3. So of course I have to evaluate this first before I can decide if I'm able to go into my while loop. Remember, it's possible a while loop's condition might be false right away, so we have to check. So is 1 less than 3? That is true. So yes, indeed, we are going to be allowed into this loop. So we go in, and the first statement we see is one that creates a new variable called y, and we initialize y, of course, to a value of 1, like we have been doing. Once I've set up y and initialize it to 1, I then encounter this do, which of course means we're about to enter a bottom checking loop or a post-test loop. So I enter the do, and the first thing I see is a print. This is the same print we had in the previous example. So it's going to print the letter x, and it's going to wait on that same line in case there's another output. Once we've finished printing the variable x, we can then increment y. Be careful when you're doing these in rough work that you increment the right variable. So I go to my y, I'm going to increment it by 1. It now becomes 2. Once that's finished, I then hit the end of my do loop. I must evaluate this condition, y less than or equal to 3. Of course, y right now is 2, so that means this is true. That means when the bottom checking while loop, when its condition is true, we are going to loop up to the do. Again, it's just like the for loops. We have to finish all the iterations of this inner loop. We're going to loop back up to the do, and we're going to redo it. We're going to iterate it again. So inside the loop, we see the print. We're going to print x right where we left off on the same line. So we've got that done, and then we're going to increment the y. So we go to our y, we increment it to 3, and then we hit this while statement where we must evaluate our condition to see if we're allowed to do another iteration. So is y still less than or equal to 3? Well, it's 3, so that is true, which means we're going to go back up to the do again, and we're going to enter this loop. We are going to print the current value of x on the same line as before, and then we are going to increment y. So y was 3, it now becomes 4. Then, of course, we hit the while statement. We have to reevaluate our condition. Is y, which is 4, still less than or equal to 3? No, this is false, which means our inner loop is now finished. So we've completed one full iteration of our inner loop. We have to keep going, though. So our next statement after the inner loop is a statement that increments x. So we go to x, we increment it to 2. Then this system.out.println. Remember, our last output left us right here after that last X. This is going to bring us down to the next line of output. So that means the next thing that's output is going to go on the next line after or below that letter X from the previous line. So that's done. We hit this closing brace. Again, that means we have to iterate back up to the top. Again, when you look at your braces, the do while braces are pretty easy to match. That means this while loop brace matches that while loop brace. So we're going to loop back up to the top of this while loop. So we have to reevaluate our condition to see if we're allowed to continue. Is X still less than 3? Yes, this is still true. So guess what? We're going to go in and do all this again. So we've done one complete iteration of our outer while loop, and we are now going to begin the second one. So again, this is declaring and initializing a new version of Y. So this is all gone. It's disappeared. It's not in memory anymore. And we start off with a new value of Y. This guy's going to get in the way, so I'm going to put him down here. So we start off with a new Y. So we've got a new Y, and then we start our do loop all over again. So we're going to print X. Remember, our X is going to go down here because that's where we left off. We're going to take our new Y. We're going to increment that to 2. So I'm going to put my check marks over here so we don't get them confused. So we did that one, and we did that one. Then we evaluate our condition. So we have to create one. Is Y still less than or equal to 3? Yes, because Y is 2. 2 is less than or equal to 3. Sorry, that's really ugly, but it's true. So that means that when we evaluate this to true, we loop back up to the top, and we're going to do this again. So we go in and we print X. You know what's going to happen. We increment Y to 3. And then we reevaluate our condition. Is this still true? Yes, Y is still less than or equal to 3. So guess what? We're going to do this again. We're going to print X, and we're going to increment Y to 4. And then when we hit the while loop, we're going to have to reevaluate. Is 4 less than or equal to 3? No, that's false. So this loop is done for the second time, and we now continue with the rest of our program. We are going to now increment X to 3. We are going to add a new line to the end, so our next line of output goes under the first letter from the previous line of output. And then we see the closing brace for the outer loop. So we loop back up to the top of our outer loop, and we see if we're allowed to do another iteration. So we reevaluate. Is X less than 3? Guess what? It's not. It's false. So that means the outer loop is now finished. So we've done 2 iterations of our outer loop. We did 2 iterations, or 2 complete sets of iterations of our inner loop. The inner loop itself iterates 3 times. So that means this time we got 2 rows. So if our inner loop on its own executes 3 times, 1, 2, 3, so we got 3 X's, 1, 2, 3. And then our outer loop iterated twice. So we got, there's the first row for the first iteration, and there's the second row for the second iteration. So we got 2 rows of 3 X's each. So here I just sort of copied over the output we got from this set of nested loops, 2 rows of 3 X's each. So what's interesting to note is, as we mentioned earlier, this do loop, when we do the whole loop on its own, it executes 3 times. This corresponds to each X inside. So these X's, 1, 2, 3, those are the 3 times that's created by our inner loop. So our inner loop always prints an X, and it does it 3 times. This outer loop here, this outer loop executed twice. So this one executed 2 times. So this outer loop corresponds to the rows in each output. So in this case, this was our outer loop. So our outer loop was responsible for printing the rows. Now, without retracing this code again, what do you think would happen to this output if we changed the condition of this loop here to X less than 5? Think about that for a moment. How would this change our output if we changed the 3 to a 5 so that our loop, our outer loop, was while X less than 5? So if you think about that, Since we start our loop at 1 and we go up 2 but not including 3, that's 2 iterations. That makes sense. We already established that. So if I change the 3 to a 5, we're going up 2 but not including 5. That's 4 iterations. So if we changed the while loop to x less than 5, that would give us an extra 2 rows. So we would get an extra 2 rows of x's. Cool. Now think about this again, except what if I changed instead, I changed the inner loop from y less than or equal to 3 to y less than or equal to 5. We'll do 5 again. So how does that change the output? If I change, instead of the outer loop, if I change the inner loop to y less than or equal to 5. So think about that for a moment. So since I'm starting y at a value of 1, and I'm continuing as long as it's less than or equal to 5, so from 1 to 5, including 1 and including 5, that would be 5 iterations. So that means instead of 3 times, this loop would go 5 times. So that means one iteration of this do loop would give you 5 x's instead of only 3 x's. So if we left the x less than 3, but changed the y less than or equal to 5, then we would get 2 rows of 5x's. So as we mentioned before, printing data in rows and columns is a really common thing. We do it all the time. And when you print data in rows and columns, your outer loop counts through the rows, and your inner loop counts through the columns in each row. An easy way to remember this is that you encounter the outer loop first, so we think rows first, and we encounter the inner loop second, and that's the one that counts our columns. So we have rows first and then columns. Now, if you were on the Titanic when it was sinking, the first thing you'd do is get into a lifeboat and row away from the sinking ship, and then you would column for help. So that's how you can remember. First you row, and then you column. When we're in the actual classroom, I actually make motions. I make rowing motions, and then I kind of put my hands up around my mouth and say column. So first you row, and then you column for help. And I know this is stupid and ridiculous, but if you remember that, because it's ridiculous, you won't forget. So just think of it in your head. Think of yourself rowing in a boat. First you row, and then you column for help. There you go. Now let's try a programming example. Let's use nested loops to print a multiplication table from 1 to 12. So I don't need a scanner for this program unless you wanted to ask the user from 1 to n and then do a table from 1 to n. That's fine. You can do that as an extra practice exercise if you want, but I'm just going to do 1 to 12. So what I need to do first is think about how my output is going to look. If we actually go back and look at the example, we can see that I've got 12 rows and each row has 12 values. So right away, nested loops. And the nice thing is it's 12 rows and 12 columns or 12 values, which means both loops are going to iterate 12 times. This is probably one of the easiest examples of nested loops you'll encounter. So I'm going to do 4 loops. Because they're counted loops, it's just easier to do 4 loops. And typically I would use I and J, but I think for clarity, I'm going to change them to the word row, and then I'm going to use COL for column. So I'm going to start off with int row equals 1, and then as long as row is less than or equal to 12. So I want to start on value 1 and go up to and including value 12. So it's always a good idea, and I think I've mentioned this before, it's always a good idea to include the important values in your code. It makes your code more readable. So because my table is from 1 to 12, it wouldn't really make sense to go from 0 to 11, right? I mean, it would still work if you coded it correctly, but it's not as readable as saying 1 to 12. So I'm going to do 1 to 12, and then of course I need to row plus plus. And don't forget to put your braces in because you don't want to accidentally make any mistakes. Then my inner loop, so what I'm going to do is use my outer loop is going to print a row. So my inner loop is going to print each of the 12 values in a single row. So I'm going to call the counter COL column. It's also going to start at 1 and continue as long as it's less than or equal to 12, and then column plus plus. There we go. So, and it's probably a good idea to add a little documentation. So this counts the rows, and then this counts the columns. Just like that. All right, so the next thing I want to do is figure out now how to get each value in each row. So again, if I look at my table, any value, if you pick any value inside this table, so for example, here I've got 48. 48 is in row 8, column 6. That's not a coincidence. 48 is 8 times 6. Similarly, if I look at 33, that's in row 11, column 3. So it's 33 is 11 times 3. Each number in the table is the row number times the column number. If I look at the 2, it's row 1, column 2. 1 times 2 is 2. So printing each value is simply going to be a matter of system.out. I'm going to use a printf, of course, and I'm just trying to figure in my head, I'm going to put a good number of spaces between each. So %4d, and we don't want a new line because we want everything to be, we want all of the values to be on a single row. And then I'm going to replace that with the row number times the column number. Nice and easy. Now you might be thinking, oh, there's more that you have to do. We'll get there. So let's give this a try. Let's just see what this does to start with. So I'm going to compile. I'm going to execute, and we see, yikes, that doesn't really look like a nice table. And in fact, it looks like it's in rows and columns, but it's not. It's actually printing all of the numbers in a single row. It's just that it's word wrapping it in the console window. So what's missing is we want to make sure that after it finishes a row, it then adds the new line character to the end. And so that means that I have to make sure that when a row is finished, it prints a new line so that when we go and iterate to the next row, it's going to be on a new line. So anything that you want done at the end of a row goes in the outer loop, but after the inner loop. So this spot right here where my cursor is, this is the end of the row. And so this is where I'm going to add my new line. All you need to do is just an empty print line. That's it. Once we do that, then save, compile, execute. There we go. There's my nice formatted table. Now, just for extra stuff, because it's a good learning experience, what if we wanted to print headers? We could do column headers, and then we can even do row headers if we want. Now, the column headers are actually really, really easy. If I want to print column headers, anything you want done before the table should go before the outer loop, obviously. So I'm going to do a quick little int I equals 1, I less than or equal to 12. This one's not rocket science. None of this is really rocket science, is it? So I'm going to do my little for loop, and I'm just going to do a quick system.out.printf. And what did I use? I used a 4. So %4d, and then I'm using I. So this will print 1 to 12 across the top, and then probably I want sort of like a line, an actual line under it. So after it prints that row of numbers, I'm going to do just a print line. I'm going to now notice that this was a printf. So the first thing I'm going to have to do is add a new line to bring the cursor down to the next line. And then if I'm doing 12 values and each one takes up 4 spaces, so that's 48. So I'm basically going to have to count out 48 dashes. 1, 2, 3, 4. And I'm just going to paste this 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There we go. All right, so that's 12 sets of 4 dashes. It should make a nice blank line underneath my headers. Let's give it a try. Yeah, that actually looks really good. Look, it lines up really nice. So there's my headers at the top of each column. How do I now display headers at the beginning of each row? So this is a little more complicated, but not impossible. As we said before, if you want something done at the end of a row, you put it after the inner loop. So think about this. What if you want something done at the beginning of a row? Where do you think that would go? It would go before the inner loop. So if I want a row header, so maybe what I want to do is put the number of the row from 1 to 12 formatted in, let's say, 3 character spaces and a little vertical line. So it's going to look like there's a bit of a vertical line there. So I'm going to do a quick little printf in here, and I'm going to print %3d followed by this vertical line, the pipe symbol. And what am I going to put for that format specifier? This is going to be the row number all the way down, 1 to 12. So it makes sense that I would use my row counter for that. Now, that means then that my numbers on the top, they're not going to line up properly anymore. I'll just show you so you kind of understand what I'm talking about. And we'll make sure that our row number, our row header works properly. So the row header, oh look, it looks nice. Row header looks nice, but now our column headers are kind of messed up and our line is off to the side. But that's because I actually added 4 characters, the %3d plus the vertical line. So I added 4 characters in front of every row. So I need to do the same thing here. So what I can do is before I begin the row headers, I'll just print 4 spaces. Again, I'm going to use a print because I don't want a new line at the end of those. So just add 4 spaces. You can't put it here because that'll put 4 spaces in front of each number across. We don't want to do that. And then before I print the lines, you could print 4 more lines, or you could print 1, 2, 3, 4 spaces. That works too. And those spaces in front of the numbers row and in front of the dashes row will line up everything. There we go. Look at that. Isn't that nice? So now we have a multiplication table and it has column headers and row headers in it. Sweet. Nested loops can also be used to analyze data. So let's say that we want a program that records grades for different students in different courses. We'd like to know the average for each course. So we're going to allow the user to enter grades for some unknown number of students for some unknown number of courses. We'll use a yes/no prompt to determine if the user wants to record another course, and we'll use a negative sentinel value to determine if the user has more grades to record. So of course we want to start with the IPO chart for this, and then we'll work on the pseudocode for the logic part of the processing. So the output for this program is we want to print the average grade for each course that the user wants to record grades for. What inputs do we need? We need the grades. So we're going to have to ask the user to enter each grade for each course that they're recording. Then comes the good stuff, the processing. So with the processing part, what we want to do is we want to record grades for each student in a course and then calculate the average as the total grade divided by the number of students. And we want to repeat that code for each course. So we've got 2 bits of repetition here. We are repeating, recording, and accumulating grades so we can calculate average. And we're going to repeat all of that for each of the courses as well. Now let's look more closely at the first task, which is recording the grades for each student in one single course. So we won't worry about multiple courses right now. Let's first look at how to do one single course. So the first thing we need to do is we're going to have a loop that iterates as long as the user entered grade is 0 or more, because remember, we're using a negative sentinel value to be our loop controller. So since we need to get the user's input in order to start comparing, you might think it should be easier to use a bottom checking loop, and that's fine. So if we want to calculate the average grade, we'll need to accumulate the grades and then get the total sum of all those entered grades, plus we'll need to keep track of the number of grades entered. So the code we want to repeat is to get a grade, add that grade to the total, and then increment the number of students. However, this means that when the user is finished entering grades and enters the negative sentinel value for the grade, that sentinel value is actually included in our calculation. It will be added to the total grade, and then we are actually going to increment the number of students for that sentinel value, which would give us an incorrect average grade. So to avoid processing the sentinel value, what we can do is switch to a top checking loop that uses the priming read, continuing read pattern. What we'll do is we'll retrieve the first grade and then check to see if it's 0 or more. If it is, we'll add that grade to the total, and then we'll increment the number of students, and then we'll get a new grade. And then we'll loop back up to the top and we'll check and see if that new grade is greater than or equal to 0. If it is, we process it and then we repeat. At some point when the user enters a new grade and it's not greater than or equal to 0, we're then going to exit the loop. Now, of course, the issue is that if the user enters a negative grade immediately, we're going to have a weird calculation. Depending on your data types, you might end up with a divide by 0 error because there's 0 students. We're going to deal with that later, don't worry. So let's code this bit first just to get it working, and then we'll deal with the multiple courses. So again, we're just going to assume right now we're doing only one course. We're not going to worry about the number of courses right now. So the first thing I want to do is I want to do my priming rate. So I'm going to do a print and ask the user to enter a student's grade. And then I'm going to retrieve that grade as a double. I think we established in an earlier video that grades are generally floating point or double values. The next thing I want to do now is begin the loop that's going to iterate as long as the grade is not a negative sentinel value. In other words, as long as the grade is greater than or equal to 0, 0 is acceptable, but negatives aren't, then we are going to repeat. So if you look back at your pseudocode, the things we're repeating, we're going to now take that grade and add it to a total and increment the number of students and then get the next grade. So this means I'm going to have a variable to keep track of my total grade. So double total grade equals 0, and I need the number of students, which would be an int. So num students equals 0. So inside my loop, I want to take that total grade and I'm going to add the newly entered grade to it. And then I'm going to take my number of students and I'm going to increment it by 1. And then I'm going to do the continuing read. I'm just going to copy and paste this code, but just undeclare grade because you can't declare it twice. There we go. So I am going to accumulate the grade. I am going to keep track of the number of students, and then I'm going to get a new grade. And then I'll loop back up to the top. And if that new grade is still greater than or equal to 0, we do it again. Otherwise, our loop is finished. When the loop is finished, I'm just going to add a little to-do here that we shouldn't do this part if there are no grades. We are not going to deal with that right now. We will deal with that before we're done, though. I'm going to now calculate the course average of all of the student grades, which is the total grade divided by the number of students. There we go. And of course, I'm going to have to print that out, aren't I? So print it out. So course average is %.1f. I just felt like 1 decimal point. I usually do my grades with 1 decimal point. Course average. There we go. So if you want, you can try it out. Test it out. Whoops. Test it out to make sure it works. So I'll enter some grades that I'll just do something easy that I can calculate in my head. So student grade 85, 84, 83, and then a -1 to quit. And perfect. My average is 84, which would be the average of these 3. So far, so good. Now the next task is that we want to repeat that whole bit of code, the whole retrieving of course grades and calculating the average. We want to repeat that for each course. So what we want to do is take that code we just wrote and put that inside its own loop that repeats for each of the courses that the user wants to record. So in this example, I used a bottom checking loop. So I used a do while, and it just makes a little more sense. If you code it the other way, you can try it out. If you want for extra practice, it's fine. There's probably a couple extra things you'll have to do. I just know from experience that this is going to be easier using a do while, which is why you should practice, because then you will know from experience as well. So I'm going to start adding that do while. When you have code and you want to add a loop into your code, you want to be really careful of your indentation. So the do is going to go up here, and then I'm going to immediately go down after I calculate and display my average and add the while. I'll fill in the guts of the while later, and then go right away and fix your indentation. or use the code beautifier if you want to, but fix the indentation right away. If you don't, and then something goes wrong, you might have a hard time trying to figure out where a logic error is because your indentation is incorrect. So make sure you fix that right away. So probably the first thing I want to do inside my do loop is let the user know that they're entering course grades. I'm going to do a quick little print line, course grades, and then a new line. And then I'm just going to leave them some instructions. Enter a negative grade to go to next course. Oh, I'm going to run out of room, but that's okay because I am going to do one of these, right? We've done this before. Oh, I gotta close that little thing there. There. So I'm just letting the user know I'm about to record a new course, and then I'm going to do all of the work of recording all of the grades for a course and calculating the average. And then once that's done, I need to ask the user, do you want to add another course? So as we mentioned in the description of this assignment, we're going to do this with a yes, no. So we're going to have to ask the user, do you want to enter another one, get the response, and continue while the user says yes. We've done this before. So I'm going to do a little quick system.out.print, enter another. Again, tell the user the kind of input you expect, and we'll grab that as a char. I obviously can't declare my char here. I'm going to have to go up and declare it up here. So I'll just call it another. It doesn't matter what you initialize this to at all. If you want to do a null, because that's pretty standard, you remember that, \0 is a null char. Back down here. So now I'm going to take that another and assign it this old thing in.next.to uppercase, because I read uppercase a lot easier. If you like lowercase, then do 2 lowercase. That's okay. Doesn't matter to the user because they can type either and it'll still work if you code it correctly. So I take whatever the user types, it's going to convert it to uppercase, even if it's already uppercase. It doesn't matter. So grab what the user types, only the first character, convert that to uppercase, which means I will continue while they keep saying yes. So another double equals y. Again, this isn't new. We've done this before. So this will now loop. Oh, I can't fit the whole thing on the screen there, but this do is going to loop the whole get a bunch of grades and calculate the average. So let's see what happens. Let's see if this actually works. So here we go. So it's asking me to enter student grades. So I'm going to do the 85, 84, 83, and then I'll do a -9, and it gives me the average of 84. Okay, so far so good. Do I want to do another course? Yes. So it says, okay, another set of course grades, do a negative grade to go to the next course. So I'm going to do 70, 71, 72. So that should give me an average of 71. I'm going to enter a negative to go to the next course. And it gives me an average of 77.5, which is a bit weird because it should be actually 71. Because if you calculate right now, if you grab a calculator, 70 plus 71 plus 72, and then you take that sum and divide it by 3, you're going to get 71. So why is it giving me 77.5? You might be thinking, that's a little weird. Maybe my math in my head is wrong. So let's do another one. So we'll enter another one, yes. So I already know that if I do 85, 84, 83, it's going to give me 84, right? So 85, 84, 83, and then a negative, and it gives me 79.7. So you must be by now thinking like, what the heck is going on, right? This is not right at all. So let's quit and we'll see what the problem is. So if we look at our code and we try to sort of not manually trace, I mean, you could manually trace it like we do if you want to, but if you look at it just really quickly, you might be able to figure it out. So if we start our do loop, we print this, and then we get a grade from the user. Okay, so I'm imagining I entered 85. And then while the grade is greater than or equal to 0, I add that grade to the total, increment the number of students, and then I ask for a new grade. So that's going to be 85. I'm going to add 85 to my total. Num students is now going to be 1, and then I loop back up to the top. I enter a new grade down here, which, what was it, 84. So it's going to take the 84 and add that to the total number of students, ask for the next grade, which I entered 83. It's going to add, so we looked at the first one, it was fine. We got the average we expected. So we're like, I don't see anything wrong. We calculate our average. The course average was whatever the total is divided by number of students. That gave us 84, which we printed. Then we said, do you want to do another course? And we said, yes. So another was equal to y. So we loop back up to the top, and then we print the prompt again, enter the number of course grades. We ask for a grade. So far so good. So I entered, I think it was 70. And then, while the grade is greater than or equal to 0, which it is, I take the grade and I add it to the total. Think about that. What's in total grade right now? It still contains the total from the previous course. So we're actually taking whatever 85 plus 84 plus 83 is, 240 plus 543, 9, 12, 252. So 252, and we're adding the 70 or whatever we entered, and then we're incrementing the number of students, which was 3 before. So now we're incrementing it to 4. So this isn't what we want. What we're actually calculating is the overall average of everything for all the courses. This is not what we want at all. So what we should actually be doing is we should be making sure that when we start a new course, so remember, anything you want done before the row begins, in this case it's not a row, but anything we want done before we start recording for a new course, we should do before the inner loop. What we should do before is reset the total grade and number of students back to 0. So you could just add statements to assign them a 0, or it's actually perfectly acceptable to take the declarations and just paste them down here. So it's totally fine. In fact, this is usually how I do it. It's not how everybody likes to do it. If you prefer to leave the declarations where they are and just change these to assignment statements, that's okay. But I have to make sure that before I start a new course, before I start recording the grades for a new course, I have to reset my total and my number of students so that it's fresh, starts with 0, and that way my average is accurate for each course. Let's see how that changes our output. So I'm going to do the same values. Now we know 85, 84, 83 should still work. So I'll do a negative. There we go. So I'm going to say yes. Let's do another one. So I'm going to do 70, 71, 72, and then a negative number. And there we go. Now it's working. So yes, another one. I'm going to just try the 85, or I'll go up this time, 86, 87. Should give me 86 when I'm done. Yes, there we go. So now it's working. So once again, when you have tasks that need to be performed before the inner loop, then you put them above the inner loop. Anything that needs to be done after the inner loop, you put after the inner loop. So if you're printing rows and columns, then anything at the beginning or anything that needs to be done before a row begins, you put it above, and anything that needs to be done after a row ends, you put it below. Similarly here, anything we need to do before we start recording the grades, we put above the inner loop, and anything that we need to do after recording all the grades, we put below the inner loop. Now, you could nest up to, as many levels as you need to. Generally, we try not to do more than 3 levels of nesting. So for example, perhaps for each course, I then want to take each student and record each exam. So that would require inside my inner loop another level of nesting. So another loop that iterates for each exam for a student. Again, we try not to do more than 3 levels of nesting. So no more than 3 nested loops. I'm sure there's exceptions to that rule, obviously, but in general practice, we try not to because it does interfere with the efficiency of your program. If you're having an issue where you've got too much nesting with loops, then it's time to stop and reevaluate. So before you started your program, you wrote out the logic. It's time to have another look at that and see if there's a different way to tackle that particular application. Now, the only thing we have left to deal with is if someone started recording grades and then decided, oh, there's no students in this class, or I didn't record any grades for these students yet. So they would enter a negative value right away. It's still going to attempt to calculate and display the average. So it's not a good idea to do that, not just because, first of all, you might get an error, obviously. Whenever you divide by 0, if you're dividing integers, it's going to crash your program. But if you're dividing floating points by 0, then it's just going to give you something called NaN, or not a number. And we don't want to see that, or at least the user shouldn't have to see that. It's not user-friendly at all. So we want to prevent that from happening. So what we should actually do is we should say, look, if there were no students recorded or no grades recorded, then don't do this. In other words, if there were students, then go ahead and calculate and display the average. So it's just an if statement. So if number of students is greater than 0, then go ahead, and again, make sure you indent as you go. Go ahead and calculate and display the average. There's not really an else for this. I mean, if it's not greater than 0, if there were no students, obviously it's not going to be negative, hopefully, but if there's no students, we just don't do nothing. We ask them for if they want to do another course. That's it. So that's a good way to kind of handle the issue with 0 students. I'm just going to give it a try to make sure it works. So if I just enter a negative grade right away, it should say, okay, no problem. It didn't display any average. It didn't waste processing calculating an average because it wasn't necessary. And I can say, do I want to enter another course? I can say yes or no. It doesn't matter. So there you go. Now, as you saw from the example we just did, you can also nest mixed structures in your programs. For example, you can put loops inside ifs, ifs inside loops, whatever you need to do really to get the program to do what it's supposed to do. So let's try another example. In an earlier video, we wrote a program that asked the user a trivia question, and we kept asking the user for an answer until they got it right. So let's modify that program, and this time we'll display a different response for each of the user answers. So you can see an example here. So if the user answered A as the incorrect answer, I'm going to display this message. If they answer C as the incorrect answer, I'll display this message. But if they answer B, I just say that's correct, and then I say well done at the end. So here's the original version of this program. We displayed a question, and then we had a bottom checking loop where we prompted the user for their answer, and we repeated asking as long as they didn't answer the correct answer, or as long as they didn't say B. We kept asking. What we'd like to do is after we retrieve the input from the user, we'd like to display different things depending on what they actually entered. This would just simply be an if, else if, or a switch statement would work here as well. I'm going to do a switch statement. So I'm going to do a switch. Because we're comparing a char answer, we can actually use a switch statement. So I'm going to do a switch statement on answer, and I'm going to do case A, case B, case C. This isn't going to be one of those fancy switches where we have a bunch of cases that do the same thing. There's no default, so this one will be pretty straightforward. So in the A case, the message we were displaying in the example was, oh, I make that a print line, was nope, coffee is an HTML editor. I don't know if it still is, actually. There used to be an HTML editor called Coffee. And we want a break. Remember, in a switch statement, you need a break after the case that's true, or else it will keep going, and we don't want it to do that. We want it to exit. And then in the B one, we're just going to print that's correct. And break. And in the C one, we'll do nope, James Gosling invented Java. All right, and we really don't need the break after the C because it's going to finish it anyway, but if you might want to add one so that if you do add more cases later, you won't forget. It's really up to you. It's not really needed, so I'm, going to take it out. So we ask the user for an answer, and then we examine the answer using a nested switch statement and decide if it's A, we print this message, otherwise if it's B, we print that message, otherwise C, we say this message. At the end, this will not terminate until they answer the correct answer, So it's okay to say well done after the loop is over, because if we get to this highlighted statement here, it means they must have answered B, because that means this condition was false and we terminated the loop. Let's give it a try to make sure it works the way we intended. All right, so I'm going to answer C, which is incorrect. It says, nope, James Gosling invented Java. I'm going to enter A, which is incorrect. It's going to say, nope, that's an HTML editor. So I'm like, well, the only answer left is B. Yep, that's correct, and well done to me. So there you go. We've got a loop with a switch statement, or if you chose to write it as an if-else if, that's fine, but the switch statement was probably easier. But you can do nested ifs inside loops. That's totally fine. So let's look at the IPO chart first, of course. So we have, for our output, one of two messages, whether or not the user won the $100 prize. What inputs do we need? We either need the ticket number or we need the number of biscuits. If they enter a ticket number that's 0 or less, we're going to have to ask them for the number of biscuits in the jar. Now the processing, there's two different processing tasks. We're going to have to obviously write both, but when the program's running, only one of these two tasks is going to end up executing. Either we check the ticket number to see if it matches one of 5 random numbers. Now we're going to have to add the code to draw 5 random numbers, or we have to also write the code to check and see if the input number of biscuits matches the actual number of biscuits. So we have two processing tasks. Let's take a look at the logic for these. First, we're going to look at the main line of logic. So the user is going to choose one of the two options. So we need to get the ticket number from the user, and then this will tell us which option they chose. If the ticket has a number, then we're going to do the random draw. But otherwise, if there's no ticket number, in other words, if we enter 0 or less, then they're going to have to guess the number of kibbles in the jar. So this means we're going to have a double-sided if statement. So let's look at each side, starting with the if block. So the if block does the random draw. So what we need to do is repeatedly generate a number 5 times. Now, under what conditions do we stop repeating? There's actually 2 conditions. First, when 5 draws are completed. So if we keep track of the number of draws or the number of random numbers we generate, we quit once we've done 5 random numbers or done 5 draws. And secondly, when the user's number comes up, in other words, when the user's ticket number is equal to one of the 5 random draw numbers, we can just quit repeating. So if we draw a number, it doesn't match, another number, it doesn't match. If we draw a third number and it does match, then we can quit. We don't need to actually draw the other 2 numbers. So this means we stop iterating when the number of draws becomes more than 5, or we stop iterating when the user's ticket number matches the random number that we've just generated. However, a while loop's condition defines the conditions under which the loop continues, not when it terminates. So we have to rewrite that bit of logic for a while loop. So this is another example of De Morgan's law in action. So first of all, let's let A be the number of draws greater than 5, and we'll let B be the ticket number equal to the random number. Next, we want to stop repeating when A or B becomes true. So this means we want to continue while not A or B. So according to De Morgan's law, this is equivalent to when not A and not B. Now, since A is number of draws greater than 5, then not A is number of draws less than or equal to 5. And since B is ticket number equals random number, then not B is ticket number not equal to random number. Therefore, we can write our while loop condition as while the number of draws is less than 5 and the ticket number is not equal to the random number. Now this should make sense since we want to repeat the random draws as long as both conditions are true. As soon as we are done 5 draws, that makes the first condition false, which terminates the loop. As soon as the user guesses the random number, that makes the second condition false, which terminates the loop. Remember, with an and, both conditions must be true. So as soon as one of those 2 conditions becomes false, the loop is going to terminate. Once we finish the loop to do the random draws, we need to know if the user won or not. So how do we know why we quit the loop? Did we quit because we ran out of draws, or did we quit because the user's ticket matched? So we can easily figure this out by comparing the user's ticket number to the last random number generated. If they're equal, that means we quit because the user's number matched, not because we ran out of draws. Now the next thing we need to do is look at the else block of the main logic, and this is where we're guessing the number of kibble biscuits in the jar. So the first thing we need to do is retrieve the user's guess, and then we have to take their guess and see if it's equal to the actual number. I think it was 524. Otherwise, they're not a winner. So let's try coding it now that we have the logic figured out. Okay, so the first thing I'm going to need to do, obviously, I need to get the ticket number because the ticket number determines everything. So enter the ticket number. So the user's already gone off and bought a ticket, and then they've come up to someone sitting at a computer or whatever and said, here's my ticket. So we're going to grab the ticket number as an int. There we go. So if we look at the first bit of logic, we've got the ticket number. We want to see if the ticket number is greater than 0, we're doing a draw. Otherwise, we're doing guess the number of biscuits. So we're going to do an if statement. So if the ticket number is greater than 0, that means we're doing the random draw. Otherwise, we're guessing biscuits. There we go. So let's tackle the if block first, just like we did when we did the pseudocode. And this is the more complicated of the two, but it's not ridiculously complicated. So we want to do a loop that repeats while the number of draws is less than or equal to 5 and the ticket doesn't match any of the random numbers. We're going to basically generate a random number and then keep track of the number of draws. The while loop condition is going to take care of the rest. Top checking or bottom checking, it doesn't matter, but I think the bottom checking would be easier because we want to start by generating some numbers and then comparing them, right? So kind of makes sense to do this with a do loop. But again, if you want to do this with a top checking while loop, that's fine too. You can adjust it probably pretty easily. Now I need to know how many draws. So we need to keep track of the number of draws. So I'm going to initialize that to 0. I'm going to need to generate, I believe it was between 1 and 1,000. So I'm going to need to generate a random number. So we're thinking, okay, double random number equals, we use the standard, sorry, my fingers are lined up on the wrong keys. There we go. The standard random number formula, math.random times, in this case, 1,000 plus 1. Like that. So that'll generate a random number between 1 and 1,000. And then we're going to increase the number of draws by 1. So our while loop condition, again, if we look back at our pseudocode, while loop condition is going to be while the number of draws is less than or equal to 5 and the ticket number doesn't match. So while num draws less than or equal to 5 and now we've got an issue because we want to compare if the ticket number that the user typed in to begin with is not equal to the random number. Now the random number, we declared it inside the do while block, which means it's not accessible here. So we're going to have to undeclare it here and declare it out here and initialize it to 0. It actually doesn't matter what you initialize it to, but you do have to initialize it to something. So we're just basically going to give it a new value once we get into the loop anyway. So we have to make sure that random is declared here, otherwise you won't be able to access it outside the while loop. I know it's silly, but that's just the way it is. Once that's done, that will loop either 5 times to generate 5 random numbers. More likely, that's what's going to happen. It's going to iterate 5 times. The chances of matching a number are pretty slim. The only other way it'll terminate is if they actually do match one of the random numbers to the ticket number. If one of these numbers matches, it quits right away and doesn't continue drawing random numbers. So that's fine. And then if we look back again at our pseudocode, once that's done, we want to check and see if the ticket number is equal to the most recent random number. That means that we quit this loop because they won. Woo! So we're going to add an if statement for that. So if the ticket number is in fact equal to our random number, yet another reason why we need our random number outside of the while loop because we need it after the loop as well. So if that's true, we had a message to print. What was the actual message? You won $100. Hooray. And on the other side, if we quit and it wasn't because this is true, it means we must have run out of draws and there was no match. So that means we lost. Boo-hoo. So what's our message? Sorry, you didn't win, sad face. There we go. Ta-da! All right. So that's our if block. If we do enter a ticket number greater than 0, we're going to do 5 random draws and then see if one of those matches. We can actually run this program right now as long as you enter a ticket number that's greater than 0. Now, obviously, the user's ticket number obviously isn't greater than 1,000 either. So you could actually, it wouldn't be wrong to say, and it's also less than 1,000 or less than or equal to 1,000, I guess, as well. And then we'll have to, I guess, later maybe just assume if it's an invalid ticket number in general, then it's kibble biscuit time. That's cool. Sounds good to me. So I'm now going to compile and execute and just try the if block. So I'm going to have to enter something that's greater than 0, but also less than or equal to 1,000 in order to test it. And obviously I didn't win. Now, if you want to debug this and make sure that it is actually terminating properly when it matches, what you can do is you can just add a quick little if statement. This is for debugging only. So you would say debug like this and add a quick little if statement and just say, if I'm on, just pick one, like the 3rd draw. So if I'm on the 3rd draw, then just take my random number and assign it the ticket number. Just for testing purposes, right? So what this will do, don't leave this in your program because, you know, that's how bad things happen with lotteries, right? So, you know, you don't want to leave it in there. So just, we'll pick one of the draws. Pick the 3rd draw. On the 3rd draw, I picked the 3rd because it's right in the middle. And then just assign the ticket number to the random number, and then that will make this false so we can see if it actually exits properly. Again, this is something you wouldn't normally do. It's only for debugging. So we'll try it out. So I'll enter the ticket number, and there we go. So I did actually test it out. If you want to test it even further, you could print the draw number as you go, but I'm pretty sure it's fine. But there we go. So we were able to test that out and just made sure that works. Now, you could comment this out or just delete it, but don't leave it in there. Either comment it out or delete it, one or the other. So that's our if block. Now we need to tackle the else block. This is actually way simpler. So what we're going to do is we're going to guess the number of biscuits. So we're going to have to get the guess from the user and then check to see if the guess equals the actual, which again, I think I'm just checking my notes here. It's 524, which I'm going to put in a constant because then I don't have to worry about it. So I'll do that now. So I'm going to just go up here and just create a public static final. This will be an int, and I'll call it num kibbles or biscuits, whatever works, 524. There we go. So now I have num kibbles. That's the number of kibbles in the jar. And I'm going to now ask the user, enter your guess. There, and I'm going to retrieve it as an integer. All integers today, all integers all the time. In.nextInt. And now I just want to check and see if the guess is equal to num kibbles. So if they guessed it correctly, not very likely, but you never know, then I'm going to print, and maybe your brain is going, wait, this is redundant. Yes, it is. We'll fix this in just a second. And then else, I should do all this first before I start coding the body of these if statements. Look at this. When you catch yourself going there and then like that, that's bad. You shouldn't copy paste code like that. We are going to fix this, but we're going to get it working first. So if we entered a ticket number that was invalid, we're going to assume that's because they want to, instead of buying a ticket and doing a draw, maybe they figure their odds are better if they guess how many biscuits or how many kibbles are in the jar. So we say, okay, great, give me your guess. And if it matches, they win. Otherwise, they don't. So let's try that side out, compile and execute. I did save already. So enter your ticket number. So I'm going to say 0. I want to guess how many kibbles. So I'm going to guess, about 500. Sorry, you didn't win. There we go. So I typed in a guess. It did not match. And so it said, sorry, you didn't win. You could actually test this one on both sides too. Enter ticket number 0. And now this time I'm going to enter the correct guess because I got inside information and I happen to know it's 524. And yay, I just won myself $100. Oh, I must not have put a new line at the end of that. Did I not do a print line? No, I didn't. There we go. Not a big deal, but it looks nicer. Okay, we have some redundant code. We've got an if statement here that says if they win 100, otherwise sorry, and we got the exact same thing here. You shouldn't have redundant code like this because if someone decided we're changing the amount or we're changing the sorry message because people thought we were being too sarcastic or something, then we've got to edit 2 blocks of code. If we had multiple options for competing in this contest, we might have more blocks of code to edit. We don't want to do that. So that's okay. There's actually a really easy way to fix this. First, I'm going to cut this and paste it down here so I don't lose it. And I'll move that out of the way. So what I want to do is, if all of this happens and then I get to here, I just want to know if they won or not. So what I can do instead is I can use a Boolean variable, and I'm going to use the same Boolean variable in the else, and I'm going to need access to that Boolean variable after this big main double-sided if statement. So I'm going to create my Boolean variable up here, and I'm just going to call it isWinner equals false. I'm going to assume at the beginning, not a winner, because it's really hard to win this contest. So we're going to assume they're not a winner. Then what I'm going to do is after the draw, I'm going to, and you don't need an if statement. We talked about this in like a couple of weeks ago. If you don't need an if statement or a conditional, don't use it. I'm going to say isWinner equals, and then our condition for being a winner of the draw was if the ticket number matched the last random number we generated. So if this Boolean expression is true, it's going to store true in this variable. But if this expression is false, it's going to store false in this variable. Okay, now I'm going to do the same thing here. So I don't even need this whole if statement in the else block. So I'm going to say isWinner should receive a value of true if the guess is equal to the num kibbles. There we go. So if this expression evaluates to true, it's going to store true in this variable. But if this expression evaluates to false, it's going to put false in this variable. Then, let me just fix the indentation on this guy. Then all I need to do is not compare the ticket number because we already did that. I'm just going to say if, oh, my caps lock was on. If isWinner, and I accidentally deleted a parenthesis, if this variable from either this expression or this expression contains the value of true, they won $100. But if not, then they didn't win. So the user isn't going to see any difference at all, but your code is, we would say, elegant. It's a lot more elegant. It's easier to read, it's easier to edit and maintain, and it's easier to expand upon in the future. And that's the goal. Remember, learning programming isn't just about memorizing code. It's actually not about memorizing code at all, because you can look up code anytime you want in the real world. It's about writing efficient code, and code that is going to be easier to modify later in the future. There we go. So that's what we've just done. If you want to test it out, make sure it still works. It's a good idea. So I'll test out both sides. So enter a ticket number, so 242, sorry I didn't win, boo-hoo, so sad. And now I'm going to re-execute it, enter ticket number 0, because I want to guess how many kibbles, 333, nope, didn't win. And you can go back and test you can do the random number on the third try, we can test the kibbles again, that's not too bad. 524, still works. Cool. So there we have nesting and stacking and all kinds of really cool things. We're starting to get into programs now that are going to have this kind of complex logic, so this is good practice. Speaking of practice, now that we've done a couple of examples of programs that use various nested structures, it's a good idea to take the time to do the practice exercises in the notes and stuff. Now, do take the time to do those IPO charts and the rough sketch of your processing logic before you start coding. You can do it as flowcharts if you're familiar with them. You can do it as pseudocode. It doesn't actually matter. Just do something. Sketch out your logic on paper before you actually start coding. Not only does this make the actual coding easier and faster, but it will help you make a more robust and more efficient program. Now make sure you do the extra practice exercises in the notes, as I said before, and I would also recommend doing all of the programming practice exercises in Chapter 5. But in particular, if you go to the last section of Chapter 5, I've listed a couple of questions here that generally they just come up often on quizzes and exams and other assignments and stuff. So I've listed them as 5.1, 5.7, 5.9, 14, 16, and then 17 to 20. So all of the 17, 18, 19, 20. But eventually do all of them. And then there's a whole section of comprehensive questions. Those numbers I've listed there are in the introductory, like the easy ones. And then there's a set of comprehensive questions that require a lot more thought and critical thinking. So I recommend doing all of those as well. So that's it for this video. In the next video, we're going to talk about how to use nested loops and other structures to do data validation. So I'll see you over there. Thanks for watching.